In the framework of RED, or reduction of greenhouse gases emissions from deforestation and degradation, MRV is the system for monitoring, reporting and verifying the effectiveness in greenhouse gases emission reduction. Then the reference emission levels define a benchmark scenario of greenhouse gases emissions that would happen in the absence of a RED project or a RED scheme. Now, emission levels are calculated as a combination of what we call activities data and emission factors. So the activity data describes the types of land use changes and is expressed as a surface unit. And this information is generally derived from satellite imagery. And the emission factors provide an estimate of greenhouse gases emissions for a given activities data. So for instance, if we know that an area is threatened of deforestation, we can assign to this area an emission factor and calculate the greenhouse gases emissions. Then if this area isn't deforested, we can calculate the avoided greenhouse gases emissions. The emissions that would happen in the absence of any mitigation scheme. It's a reference, it's a business as usual scenario. So C4 is doing research on MRV and on emission levels, both on activities data and on emission factors. And in Indonesia, most of our research focuses on peatlands. So there are three reasons. The first one is that tropical peatlands are among the largest carbon pools on Earth. So when these ecosystems are converted, huge amounts of carbons are released into the atmosphere. The second reason is that Indonesia is one of the countries in the tropics holding the largest area of peatlands. And Indonesia is also a country where 80% of national greenhouse gases emissions are from land use change, with 50% of this 80% coming from fires and land use change in tropical peat swamp forests. And finally, there are significant gaps in knowledge and in the methods for quantifying carbon losses from land use change in these ecosystems. So when peat swamp forests are converted, we estimate that about 60 to 80% of the emissions come from the peat. Therefore, we have oriented our research in providing details on and accurate data on these emissions from the peat. For this, we use a general method which is proposed by the IPCC, which is called the gain loss approach or input-output approach. So this method consists in measuring all the fluxes coming into the peat and all the fluxes going out of the peat, and in calculating the balance. And so to make it simplistic, we could compare this peat carbon stock to a bank account and calculate how much money is saved or lost during the year by making the balance of the transfers in and out of the account. Now if we go back to the peat, so the main carbon inputs to the peat are from litter fall and root mortality, and carbon goes out of the peat through peat decomposition, fires, methane emissions and soluble and physical removals. In this specific project, so the three PhD students are focusing their research on one or two of these fluxes across one of the most common land use change type that we find here in Indonesia, which is peat swamp forest conversion to oil palm plantation. So Sebastian Persch is quantifying carbon inputs through root mortality. Louis-Pierre Como is assessing how much carbon is entering through lithophile and how much carbon is lost through peat decomposition. And Jody Hartill is measuring the fluxes of methane and nitrous oxide, and also the losses through soluble and physical removal. In their natural state, these ecosystems are waterlogged, so you don't have you have a very low decomposition rate of the organic matter. So it accumulates, and that's how the peat builds over millennia. And once you drain, you reverse the situation, and the carbon that has been accumulated is starts decomposing and emitted as CO2 or methane. So Indonesia is one of the greatest emitters of greenhouse gases in the world, and as I said, a great part of these emissions are from the peat. So climate change mitigation schemes in Indonesia should therefore focus on protecting these peat swamp forests. However, the implementation of such schemes depends on the supply of reliable greenhouse gases estimates. Especially for a scheme like RED, which aims at protecting forests, it's very important. And so now these estimates of reference emission levels and our potential estimates of avoided greenhouse gases emissions are not appropriate. So we really need, I mean, it's urgent now, and it's very important to provide better estimates of these fluxes. So at C4 we are now 4 scientists involved in the writing of a new chapter for the IPCC National Greenhouse Gases Inventories. So this chapter is specific for wetlands. In the different chapters there was a section specific for peat soils, but actually these ecosystems are so specific that they require a chapter for themselves. I mean, not only peat, but also you have other rich soils, carbon-rich soils like mangrove soils. We were able to provide emission factors for peat swamp forest conversion to both oil palm and acacia plantations. And now with the research that is going on the ground in Berbach, but we are also starting some new research in Tanjung Puting in Kalimantan, we will be able to refine these estimates for the conversion to oil palm plantation. And then we have also recently released an emission factor for the emissions of nitrous oxide following nitrogen application in oil palm plantations on peat. So, yeah, usually when we monitor the greenhouse gases from an ecosystem, we monitor carbon dioxide, methane, and nitrous oxide. And so methane and nitrous oxide are very important because their global warming potential, or their capacity in heating the atmosphere, is respectively 25 and 300 times more powerful than CO2. So that's on one hand. On the other hand, their concentrations in the atmosphere is much lower. But in cases of agricultural systems where we have high nitrogen inputs, we can have high emissions of nitrous oxide. So we need to make sure that these are not too high. There are ways to reduce them by reducing the fertilization without reducing the productivity of the systems, actually. We are investigating this now in all palm plantations on peat, because when the land has been recently cleared, opened, the soil is very poor in nitrogen. So actually the fertilization rate is quite high for allowing the palms to develop well. And so during these 3-4 years, we may have significant emissions of nitrous oxide. After that, they can reduce the nitrogen application, because the peat, the nitrogen which is in the peat is becoming more available for the plant, so they can reduce the application. But still there is, there is fertilization, and there are emissions of nitrous oxide. In terms of peatlands, I think especially after land use change, the big story is about CO2, because the soil is completely changing of state from a waterlogged condition to a drain condition, and then this speeds up the decomposition as CO2. It's challenging to work in these virgin ecosystems, which are usually located in remote areas. So it's difficult to access through the rivers, through the swamp, and we also have to face the local biodiversity with the tigers, the snakes, the orangutans, and the monkeys. But it's also challenging, because there is a lot to learn about, a lot to discover, and we are really looking forward to verify our research hypotheses.